If you like math puzzlers, you may have seen this one once before. Why do mathematicians confuse Halloween and Christmas? But before we answer that one, I'm going to have another puzzler for you. It's the circumference of a pumpkin. What do you get when you divide the circumference of a pumpkin by its diameter? As you might remember, circumference divided by diameter equals pi, because pi times diameter is the circumference of a circle, the circle in this case being the pumpkin. So what do you get when you divide the circumference of a pumpkin by its diameter? Well, you don't just get pi, you get pumpkin pie. Nerdy math joke. Now, back to the topic of the video, which is why do mathematicians confuse Halloween and Christmas? Because October 31st equals December 25th, or, in order to start guiding you in the right direction, Oct 31 equals Dec 25. What does that mean? This has to do with base 8 versus base 10. So Oct 31 means 31 in base 8, and Dec 25 means the number 25 in base 10. The numbers that we use and that we are familiar with in everyday life are base 10, so like 50, 60, 125, those are all numbers in base 10 and they equal themselves. Now for an example, 128 in base 10 equals 128 because the formula, as we will see shortly, is 1 times 10 to the second, the first digit, plus 2 times 10 to the first, 2 is the second digit, plus 8, the third digit, times 10 to the 0 power. And that, of course, adds up to 128. Now, what does it actually mean for a number to be in a certain base? Because when I first saw this, when I was taking my introductory college math class, I found this very confusing, and I only understood it very recently when I saw the October 31st and December 25th joke. It has to do with the base numbering system. So a number n, like we saw 128, with d digits, 128 has 3 digits, continuing with our example, up to m digits in base b. Your number, like we said earlier, 128, has 3 digits, so m equals 3 digits, and it's in base 10, so b equals 10. Now the formula for what 128 in base 10 would actually equal is the first digit times the base raised to the power of m minus 1. Now m, again, is the number of digits in the number. So that's the first term. The second term is the second digit times base b raised to the m minus 2. And you keep going and going until you get to the final digit times base b raised to the 0 power. The formula for the value of a number in base b, once again to recap, is the first digit times the base raised to the m minus 1, m once again being the total number of digits in the number, plus the second digit times base b raised to the m minus 2. Keep going and going until you reach the final digit times base b raised to the 0 power. Earlier we looked at 128 in base 10, but what if 128 was in base 8? What would this number actually equal, because it's not 128? Using our formula, we can say that we have 3 digits. Digit 1 is 1, digit 2 is 2, and digit 3 is 8. Our base is 8, so b equals 8. If you break it down, 128 in base 8, you take your first digit, which is 1. You multiply that by the base 8, and you raise that to the power of 3 minus 1, because we have 3 digits, and according to the formula above, the first term will be multiplied by base b raised to the m minus 1. The second term is, well, the second digit is 2 in 128. That's multiplied by base 8 raised to the 3 minus 2, continuing to follow our formula. And for the final digit, digit 3, that's 8, multiplied by 8 to the 0 power, as final term in our formula shows. This equals 64, because 1 times 8 to the 3 minus 1 is 1 times 8 squared is 64. 2 times 8 to the 3 minus 2, 2 times 8, that's 16. And then 8 times 8 to the 0 power is 8. That totals to 88. And as we saw, 128 in base 10 is 128. 128 in base 8 is now 88. So it's completely different. Now let's return to why does Oct31 equal Dec25? You can see where we might be going with this based on the formula that we just created. For Oct31, that's 31 in base 8. We have 2 total digits, so m equals 2, b equals 8 for base 8. Our terms, if we multiply them out, are 3 times 8 to the first power, because 3 is the first digit. Base 8 to the m, 2 minus 1, so that's 8 to the first power. And then the last digit is 1 times 8 to the 0 power. That equals 25. Now, Dec25 is 25 base 10, which should be pretty self-explanatory, is 25. So Oct31, 31 base 8 is 25, and Dec25, 25 base 10 is 25. So this, ladies and gentlemen, is why Oct31 equals Dec25, and why mathematicians confuse Halloween and Christmas. Another nerdy math joke. One final thing I'll leave you with is 1 in any base will always equal 1. 1 in base 10, base 8, base 6, base 25, it'll always equal 1. I'll let you guess why. Just use the rule, the formula that we presented, and try it out, and you'll pretty quickly see why this is the case. Thanks for watching.